Alright, so the basic premise of this video is that I sleep through my alarm constantly. I am going to make an alarm clock that incorporates a tens unit. This tens unit is going to shock me awake. That's the entire premise of the video. An alarm clock that electrocutes people instead of an alarm to wake them up. It's a super simple concept, but a very difficult thing to execute when you're like me and are super new to building things with electronics. Please enjoy the process that I have documented. On YouTube, ELEGOO has a tutorial for an alarm clock. I followed their alarm clock tutorial in order to make the alarm clock that I used for this project. The links to that channel and its video are in the description. Additionally, the circuit diagram for the alarm clock was taken from that video. But in all seriousness, the ELEGOO tutorial for the alarm clock is actually really well made. There are a few inconsistencies and things that I had to figure out myself. A few examples of this are the analog in pins on the Arduino. These 3 pins are connected to 3 buttons. The issue is the video shows the buttons getting connected to the wrong analog pins. The circuit diagram shows the correct location that those buttons should get attached to on the Arduino. Additionally, in the video, the NPN transistor gets attached to the breadboard in the wrong way. Once again, the circuit diagram demonstrates the correct way to attach the NPN transistor to the circuit. So the video does have some issues with it, but the diagram demonstrates the correct way to set everything up. So overall, it works out just fine. Now, I'm just going to go out on a limb here and just say I got back from working a bit on my design. I put together everything and it works. Sort of. Everything that I did works fine, except I may or may not have damaged / attached poorly a potentiometer. Basically, this potentiometer that I can't really replace may or may not be working entirely wrong, or not at all. Spoiler alert, it's not working at all. So, I am going to see if it's just shorting between ground, or if I need to order a new one, or if I need to just do the simple thing, accept that half of the tens unit is broken, and swap over to the other half, because I could do that as well. So basically, now that I've got everything sort of worked out, I just need to do the work to fix my mistakes, and then it should have, I should have everything functioning. It should be great. It'll be awesome. It'll be cool. And I will explain to you what the circuit is like, I don't know, now? Yeah, now sounds good. So, take a look at this. This is a diagram of the tens unit I am using for this project. You may notice that there is a green rectangle, a green circle, and a red circle. The green rectangle represents one of the tens unit's electrical pulse font buttons. These buttons toggle presets of pulse patterns. These patterns change not only the intensity of the tens unit, but also the way its shocks function. The green circle represents a potentiometer that's fully functional. This potentiometer controls the power intensity of the right channel. The intensity ranges between 0 and 10. However, for my use case, I only need it to be set to 10. Additionally, attached to this potentiometer is a switch. This switch is an on-off switch. It turns on and shuts off the right channel, and only the right channel. This is due to the fact that the individual channels are independent of one another. The red circle is the potentiometer that controls the left channel. It's functionally identical to the right channel potentiometer. However, when I was soldering to the on-off switch for the left channel, some metal debris both bridged contacts on the potentiometer and caused friction, preventing the potentiometer from functioning properly. Additionally, it prevents the on-off switch from functioning properly. This is causing some issues because I am unable to remotely control the tens unit without both the font button working and the left channel on-off switch working. The method I'm using to remotely control a button and a switch is relays. These relays are connected to a microcontroller, which in this case happens to be an Arduino Uno. The Arduino has the ability to communicate with the alarm clock. This is partly due to the fact that the Arduino is the brains of the alarm clock. So when the alarm is supposed to go off instead, the Arduino trips the relays in a specific sequence that simulates switching on the tens unit in the way its manufacturers intended it to be switched on.
I just need to finish that circuit. That one potentiometer, fix that, and it'll work. Hopefully.
As I've previously mentioned before, I am controlling the on-off switch and font button remotely. The method I am using to control them remotely is relays. I am using two relays. These two relays draw too much current for my microcontroller to power them. Additionally, my microcontroller is already powering many other things in order to have the alarm clock function the way that it does. So, I'm powering the relays off of a 9-volt battery, which has its voltage stepped down to 5 volts through a little chip that I own. Those 5 volts then go to a breadboard that is connected to both the microcontroller and the relays. This allows for me to connect the microcontroller to the relays to the power, and also have full control over it overall. Essentially, all that I've done is incorporate a power source, a data source, and a subject that is required to be controlled remotely. This, however, is a little bit more complicated than it seems. This is due to the fact that relays use magnetic coils and a ball bearing in order to switch on and off. The issue with this is that if they are not in a module form, they are capable of backfeeding more than 10 volts into the microcontroller. This is terrible for the microcontroller and would almost certainly break it immediately. Luckily, you can create your own module out of the components that are in the module to prevent this backfeeding current. However, it is really a messy process to do. I already had one relay module, but I needed a second one. And so while I was waiting for the second relay module to arrive, I created my own as a placeholder. The following footage is me creating that placeholder. As you can see, I am using reference images on how to hook up and create a relay module out of individual components. The reference images I am using are from this channel, more specifically this video. Overall, I used 12 different reference images. If you want to learn how to hook up a relay as though it is a module, then you should watch the video. It is linked in the description. Additionally, the method that I used to connect wires from the tens unit to the relays and wires from the Arduino to the relays is subtractive manufacturing. In other words, I drilled a hole through the side of the case for the alarm clock, and I dremeled out a little notch in the side of the tens unit that allowed me to route wires through it. Then, for a final bit of polish, I designed and 3D printed a add-on that would go onto the side of the alarm clock case, which would hide a breadboard that the relays are connected to, and it would also act as a place to attach the tens unit to the alarm clock. Yeah, honestly, that music makes it sound like it's an innovative thing. It's literally just an alarm clock that shocks me. I don't know why I put that music there.
Now I've actually kind of got it built. That's done by future me. Right now I've got nothing working at all. Point is, everything is built at this time frame in the future. And I guess now I'm just going to show it working. So enjoy that, I guess. And actually, I'm going to talk a bit after I show you this about some of the actual practical applications of it.
Alright, so now I've set the alarm. I have no idea when it's going to go off, but it's going to go off soon. And I guess I'm just going to fast forward the time in post to to when I get shocked. Just gonna, there we go, turn that on. Okay. Sorry, I'm tangled up in a bunch of wires here. This is gonna be something else. Ow! You can kind of see it here. I'm not doing that. Let me just, yeah, let me just turn that off. It works. It works. That'll work. I forgot to mention, because it's kind of just like a prototype and thrown together, there's not an off switch for when it's electrocuting you, so I had to unplug it. So I'm keeping that as a feature. That's a feature of it. You have to unplug it. That's a good test.
So now that you've, seen what the alarm clock can do, you've seen me getting shocked from a tens unit for no real practical reason. Wrong. There's actually an awesome practical reason, because I actually do sleep through my alarm very often. And I'm not sleeping through that. I mean, I'm probably not going to use it a lot or at all, but just, prolonged use could potentially be bad. I haven't done research on it. I'm not a medical professional, quite far from it. But, if you could find a less aggressive method of waking someone up that's still not as loud as an alarm and more effective than an alarm, then you can actually really have some awesome alarm clock solutions. Basically, I just want to go into a little bit of detail about what my last project was. For reference, my last project was kind of just a flamethrower that's activated by acceleration. I used this awesome little chip. It's called the MPU 6050 accelerometer and gyroscope. Actually, I think it's gyroscope and accelerometer sensor, but regardless of the order, it's both an accelerometer and a gyroscope. I only used the accelerometer portion, but it's an awesome chip, and I used the accelerometer data of a punch to safely activate and deactivate fire. So here's some of the physics behind that.
This footage was originally recorded in 240 frames per second. However, due to the compression and the frame rate that the video that you are currently watching is in, it has been lowered down to 24 frames per second. This is unfortunate because the footage is no longer in slow motion, meaning that I can no longer accurately track the acceleration and deceleration of my punch. However, my calculations don't need to be super exact. My calculations only need to be accurate enough for me to determine that I exceed an acceleration value that is positive and a deceleration that is negative within a certain time frame. Essentially, everything that I've just said boils down to if your accelerometer on the flamethrower detects a certain pattern of values, then it will turn on and off the gas for the punch-activated flamethrower as long as you pass a certain threshold of positive acceleration and then immediately afterwards, within a certain time frame, pass a negative threshold of acceleration. Once this is successfully done, the results look something like this.